Hi, and welcome to Data Structures in Java Classes. These are the concepts. I'm Norman McIntyre. Let's get started. So a data structure is a collection of data, the relationships among the data, and the operations that can be applied to the data. We've said this several times throughout the course, and we'll continue to say it as we go through this. Data structures hold objects, and objects we know are instances of classes. Since the objects stored in the data structure are created from classes, I create classes that work well with data structures. I create classes that work well with data structures. I create classes that work well with data structures. But what is a class? We can answer that question multiple ways. One answer, a class is a template or blueprint. Think of using a blueprint to build a house. The blueprint is the class. The name of the class could be house. When you build a specific house, you create an instance of the house. That is, you create an object. You can use class house to create many instances of houses. Another answer, a class is a noun. Class house, for example. Class car, for example. Class WaterMeter, for example. For each class, identify the data, identify instance data, and identify class data. Now, instance data is the data created with every instance of the class. Every object has a private copy of instance data. Class data, on the other hand, is data created one time, one single copy, for all instances of the class. Next, you identify the methods. You identify instance methods, and you identify class methods. Instance methods are called on instances of the class. That is, they're called on the object. Class methods, on the other hand, can be called at any time on the class itself. No need to create an instance of an object. A class may implement interfaces. An interface is a well-defined standard. An example, a power button is the most used standard interface in the world. You've all seen a power button. You all know what to do with it. And everyone worldwide knows what a power button does. The interface is standardized. Everyone knows how to use it. Another example, a light bulb socket. That's a well-defined interface. The light bulb interface is standardized. When you buy a light bulb, you know it will fit. So too with classes that implement one or more interfaces. Data structures often assume that a class implements one or more interfaces. For example, the comparable interface allows the data structure to compare instances of the class. The data structure may want to know, is instance A smaller than instance B? Or is instance A equal to instance B? Or is instance A larger than instance B? Data structures need to know where a given object fits in relation to the others. It would be impossible for a data structure to sort objects without the comparable interface. In summary, creating classes that work well with data structures is a key skill. I'm Norman McIntyre. Thanks as always for watching.